This simulation demonstrates the proper connection of an ammeter into a circuit in order to measure the current flow. The ammeter must be inserted into the path of the current flow to measure current. To accomplish this, the ammeter is connected in series with the lamp. The series connection is completed by connecting each component end to end. When the simulation is turned on, a DC ammeter measurement of 1.0 amps is indicated. This demonstrates the proper connection of voltmeters into the circuit in order to measure the voltage. A voltmeter is used to measure the voltage or potential difference of a load or voltage source as illustrated in this simulation. To accomplish this, the voltmeters are connected in parallel with the battery and lamp. The parallel connection is completed by connecting each voltmeter across the component. When the simulation is turned on, a DC voltmeter reading of 12 volts is measured across both the battery and the lamp. This simulation demonstrates the proper connection of an ohmmeter used to measure the resistance of a resistor. Unlike the ammeter or voltmeter, the ohmmeter operates from a battery located inside this instrument. For this reason, ohmmeters should never be connected to live circuits. Before taking a resistance reading, the multimeter is first set for the resistance measurement function and then connected across the component. Turning on the simulation indicates a resistance reading of 5 ohms. This demonstrates the connection of a wattmeter used to measure the power of a circuit. The wattmeter is basically a voltmeter and ammeter combined into one instrument. The ammeter terminals are connected in series, and the voltmeter terminals are connected in parallel with the circuit in which the power is being measured. Power in an electrical circuit is equal to the current times the voltage. Turning the simulation on and closing the switch indicates a voltage reading of 120 volts and a current reading of 0.5 amps. The current times the voltage is 60 watts as seen by the wattmeter reading. This circuit demonstrates the effect of voltage on current when the resistance is held constant. With the simulation running and the switch connected to the 12-volt battery, a current flow of 4 amps is measured. Operating the switch to the higher voltage battery, an increased current flow of 6 amps is measured. This demonstrates that the current is directly proportional to voltage. This simulates the solution to the problem presented in the text. It demonstrates how the current value can be calculated using Ohm's law when the voltage and resistance values are known. The current is calculated by dividing the voltage value by the resistance value. 120 volts divided by 10 ohms is equal to a calculated current flow of 12 amps. The current value is verified by switching on the simulation and observing the current reading of the ammeter. This demonstrates the effect of resistance on current when the voltage is held constant. With the simulation running and the switch connected to the 5 ohm resistor, a current flow of 4 amps is measured. When the switch is connected to the 10 ohm resistor, a decreased current flow of 2 amps is measured. This demonstrates that the current is inversely proportional to resistance. This simulates the solution to the problem presented in the text. It demonstrates how the voltage value can be calculated using Ohm's law when the resistance and current values are known. The voltage is calculated by multiplying the resistance value by the current value. 25 ohms times 2 amps is equal to a calculated voltage of 50 volts. This voltage value is verified by switching the simulation on and observing the voltage reading of the voltmeter. This circuit simulates the solution to the problem presented in the text. It demonstrates how the resistance value can be calculated using Ohm's law when the voltage and current values are known. The resistance is calculated by dividing the voltage value by the current value. 120 volts divided by 8 amps is equal to a calculated resistance of 15 ohms. The resistance value is verified by switching the power to the circuit off, connecting the ohmmeter across the toaster element, and observing the resistance reading of the ohmmeter.